It's the nucleus of all these other systems. I mean, you could use it in so many ways.
And you could leave it there, but it's not necessary to. You could take it to the next barren piece of land and use that. So just wanted to plant that idea.
So we can do portable aquaponic soil remediating services.
Welcome to Visionary Aquaponics, a podcast dedicated to inspiring a global aquaponics movement for food freedom, water wisdom, and permaculture-inspired aquaponics. Keep listening for the best advice from the world's pioneers and visionaries in backyard and commercial aquaponics. And now, here's your host, Maribou Latour.
System thinking. How about system thinking?
Yeah, system thinking. I love the topic of systems thinking. So speaking of systems thinking, permaculture is all about systems thinking and design using biomimicry. And it's no different with aquaponics since we're essentially designing like a river, pond, or a creek in a man-made recirculating ecosystem using pumps and gravity. Why do you think some people exclude aquaponics from their idea of permaculture?
That's a really good question. Somebody really wise once said the definition of stress is change. In other words, anytime we stop doing it, the regular, usual way we've been doing it, we can be under stress. Now, there's people who search out doing it a new way because they want the benefits of it. And there's other people who only feel comfortable doing it the old way. We had a farm tour once where we had this woman and her husband come. And for some reason, after the farm tour, Suzanne ended up talking with the husband, and I ended up talking with the wife. Now, the wife is this big, heavy organic gardener. She's like one of the most experienced organic gardeners on the island. And through the whole farm tour, she was kind of going, oh, well, you know, there's no soil involved, so it can't possibly be organic. Okay, and we kept saying, well, you know, Oregon Till, the largest organic certification agency in the world, certified us organic about a year ago. And she said, well, yes, organic certification is not really organic. That USDA certification cuts a lot of corn. I'm just kind of going, okay, how do I reach this person? You know, it's some of the freshest, purest food on the planet. So I say, okay, Nancy, let's try a thought exercise, okay? We will take all the dirt out of my garden. And that wasn't difficult because there was no dirt in my garden. And we'll take all the water out of your garden. I mean, 100%. And which one of them will grow plants then? And she spluttered and you know, and said, that's not fair. That's not fair. Of course they won't grow when you take the water out. And that's my point exactly, Nancy. Plants don't need soil to grow, as evidenced by our aquaponics system where there's no soil and this incredible growth. What they do need is nutrients carried to them by the water. And your system has nutrients carried to the plants by the water, and so does our system. It has nutrients carried to the plants by the water. The only difference is we don't have any dirt. Our nutrients are in the water. It just made her more angry.
So what do you say to people who question the nutritional content of aquaponics produce? Some people say, oh, if it doesn't grow in soil, it doesn't have trace minerals and it doesn't have all that stuff in it.
Yeah, you serve them some. No, I'm quite serious. You serve them some, it'll absolutely blow their minds. Every organic gardener and farmer who's tasted produce out of our systems has said it is the most incredible flavored produce I've ever had. What do you add to the water to do this to it? Now, I'll give you some background here. Hydroponics, which is growing vegetables in water with chemical nutrients, has long been known for its flavorless produce, okay? The tomatoes are beautiful and they taste like water, and the lettuce is beautiful and it tastes like water. Now, there are some hydroponics growers who've mastered the art of micronutrients. In addition to the fertilizer they add to the water in their systems, they add boron and calcium and selenium and manganese and every iron and everything else, all the micronutrients that plants need for good nutrition. And they measure them and they balance them so that their produce actually has fairly decent flavor. It still doesn't compare to organic grown in the soil, and it certainly doesn't compare to organic aquaponic produce. Now, you ask a question, or those people are asking a question that we've heard a lot of times before. How do you measure the nutritional value? Well, you measure the nutritional value by taking several samples at $35 each and sending them into a testing lab, and they will tell you the exact percentages of each one of the micronutrients that they have in their leaves or in their fruit. That will tell you if you are deficient in one or more of the micronutrients. Now, not only is that testing really expensive and beyond our means, but to really get an accurate picture of it, you need to test a lot of a particular plant over a fairly long period of time. In other words, you need to spend a few $1,000s to build up any kind of a meaningful data set on this. What we've done instead is we got what's called a Brix tester, B-R-I-X. A Brix testers are usually used by winemakers and brewers, people who brew beer, to determine the sugar percentages or the Brix content in their brew, because it has to be at a very certain percentage. The higher the Brix number, the more sugar and simple and complex sugars there are in the plant, and usually that goes along with good taste too. So our stuff has had fairly high Brix numbers, and it tastes really good. So while not a scientific study, we think it indicates that aquaponically grown produce has really good nutritional value also. That would be an ideal thing for an academic research environment to take on. You know, do a year or 2 year long study and spend $300,000 or $400,000 on determining what the nutritional value of aquaponic produce is. Perfect thing for a university to do.
I would say that one great measure of the liveliness of the produce grown in aquaponics is how fresh it stays after you package it. Could you talk a little bit more about the shelf life of the lettuce for your Costco production?
Absolutely. See, we went into this. We went to the University of the Virgin Islands short aquaponics course in 2007. And I went knowing quite a bit about hydroponics. I knew that the produce was generally flavorless. And that's the very first thing I do is when I got out there and had a chance, I snuck away from the class and I cut a cucumber off and a tomato, and I was evil. I stole, vegetables and lettuce and bok choy, and I tasted it. It all had incredible flavor. I was on the phone to my wife, Suzanne, that night just saying, honey, it's going to work. This stuff tastes great. Because that was my primary worry. I was worried it would be just like hydroponic produce. We didn't really do any shelf life tests until we had our bags. And we put some lettuce in a bag. We put it in the fridge. We put a date on the bag, of course. We wrote a date on the bag. That bag came out and went into town for about an hour and a half, unrefrigerated in the car, to go to the bank president who'd loaned us $100,000 to start our aquaponics farm with. Another time that Suzanne knows of, it sat out on the counter for 2.5 hours. Now, sometime later, I'm making myself a sandwich. By this time, we have lots of bags of lettuce in the refrigerator, and I just grab one at random, and I notice that it has a little bit of slimy stuff on the bottom. So I go, okay, well, I just want to pull the lettuce from my sandwich off the top of this, and I did, and it was delicious and crunchy and everything. Then I glanced at the date on the bag. It's 2.5 months. That lettuce was harvested the first week of April, and I ate it at the end of the second week of June. It was 2.5 months. Now, we've seen similar shelf lives on things that are not supposed to have shelf life, like watercress. Now, everybody who's ever grown watercress knows it's either yellow when you pick it coming off the plant, or it's yellow in the refrigerator a day or two later. Our watercress had approximately 1.5 months shelf life. And the chefs we gave samples to said it was the best tasting watercress they had ever had. So this is a huge advantage, not to be underestimated, of aquaponic produce. It has incredibly long shelf life, and it has incredibly good flavor. Now, for any commercial, like a restaurant, a hotel, anybody like that, If you have a product that has a 2-week or a 3-week shelf life, that means that buyer only has to buy it once every 3 weeks. That's a huge savings over having to bring in an order once or twice a week of a product that has a poor shelf life, which incidentally, you will have to throw out a much higher percentage of, because the poor shelf life also means a higher discard rate. It goes bad and you got to throw the stuff away. You're paying for stuff you never even got to use. This is a huge advantage for a restaurant or any commercial user of aquaponics produce.
Awesome. I'm so glad you talked about that. That's so great. Thank you. So is there anything else you want to talk about systems thinking?
Yeah. Oh, yeah. Systems thinking. So I have a great systems thinking story for you. It'll illustrate the value of systems thinking. I used to make sails for a living. I sewed sails on this big, heavy industrial sewing machine. I'd sit in front of this thing and run thousands of feet a day under the needle. One day, with deadlines and customers yelling at me on the phone, the machine totally froze up. Now, this was a sewing machine that was a lot more like a small motorcycle than it was like a sewing machine. It had a 2.5 horsepower electric motor and a clutch. If you got your finger in a way, it shoved the needle right through the bone. That had actually happened to a colleague of mine. So this machine had frozen up. I couldn't even move it with all of my force on the hand wheel, the wheel you use to turn it on the side. And I looked at it. I'd had the machine for about a year, and I was fairly familiar with it, and I couldn't see anything sticking out or anything wrong. It was simply frozen. So I did the least likely but most successful thing. I went out and I got my tools out of the truck, and instead of trying to fix whatever was wrong with it, and I had no idea what was wrong with it, I completely dismantled the entire machine. I spent 4 hours taking my sewing machine apart and putting it back together. And in the middle of that process, I discovered a tiny piece of thread down between two moving parts of the machine. It was totally invisible from the outside, but it jammed the machine up. It had never happened in the 2 years I'd had the machine. Well, I put the machine back together, and not only did I have a working sewing machine now, but I understood how sewing machines worked. That 4 hours I had invested was incredibly valuable. I can basically go to any sewing machine, and after spending about 5 minutes on it now, I understand how that sewing machine is different from the last one I worked on and the one before. So as you might understand, I fix a lot of people's sewing machines. Just sort of, we have a sewing machine that isn't working, and I heard you're good. The point of my story is that learning how to do systems thinking, teaching yourself how to do systems thinking will take a little longer, but it will allow you to solve those mysterious problems that no one understands and no one else has the answer to. Because down at the bottom of it, understanding how your system works, and what we're talking about now is an aquaponics system, not a sewing machine. Understanding how your system works makes it possible for you to figure out what's wrong with it when what's wrong with it is something new that you've never encountered before. You see, it's easy to solve problems we've already solved, right? We've already solved them. But if you get a new problem that you've never seen before, all those old problems won't help you understand it or figure out what's wrong or how to fix it. Understanding the system will. Understanding the system helps you look in the right place, and then when you do find something unusual happening, it helps you understand it. And then when you understand it, you have an idea what kind of things might fix the problem. That's why understanding why your aquaponic systems work is so important. And that's why we put so much information into all our do-it-yourself books. Way more than is necessary to just, operate the systems,
Yeah.
So system thinking, absolutely critical. Absolutely critical anytime you try something new. If you're going to try something with an aquaponic system and a permaculture system combined, you better understand both those systems really well.
Right, and how they're integrated. And They're not separate, actually. I mean, the more separate you keep them, the less efficient they are. But the more you integrate them, the more efficient all of your systems are.
Yes, it's like friends. You introduce your friend to other friends of yours. You know what? They find you have things in common. And after a while, you find you have about 10 or 12 friends who all know each other and all have different things in common, but you're all friends. That's like a really good permaculture and aquaponics system that has a number of synergistic connections where they support each other and they're good for each other.
So actually, I have this question about the fish food industry and local production of fish food. Would you like to talk about that?
I'd love to.
What do you think about black soldier fly larvae and duckweed, coconut, compost, chicken waste, native plants and weeds, all the different kinds of things that we can potentially feed our fish from local materials?
Okay. So I am going to give you strictly scientific answers, and I'm going to talk about possibilities rather than probabilities. And some of the people out there who have the worm religion or the black soldier fly religion may be a little bit offended. But I'm not talking about religion. I'm talking about science and what we can prove and actually hold in our hands. So I'm going to start this out by saying, in Chinese, there is no word for salad. Okay, well, let me explain that. The Chinese use a type of fertilizer called night soil on their fields and have for thousands of years. Do you know what night soil is?
Yeah, it was basically just
it's
poop.
The contents of the chamber pot.
Right.
And because they are, they're not a rich country, and they had to use and reuse everything. As a result, they have no word for salad in their language because they cook everything. And if you cook it, you've sterilized it, and it's safe to eat, regardless of what it had on it before. Now, when you get into our culture where we're doing, oh my gosh, we're doing all kinds of,
raw foods,
raw fish dishes and raw foods and salads and chopped salads and mixed rice and salad and macaroni, and you have incredible opportunities for contamination with fecal bacteria. Now, the deadly E. coli, it's called H70157. That's the one that 12 of them can kill a healthy adult. Didn't even exist before we started putting cattle into feedlots, okay? The cattle got put into feedlots, and cattle which are designed to eat grass and digest grass were all of a sudden being fed corn and rice and wheat and all kinds of things that their digestive systems weren't designed for. Their digestive tract became more acidic, and that allowed the bacteria in there to mutate. Sometime before the 1960s, basically you could not get an E. coli disease from a cow. After 1960s and the introduction of feedlots, that stuff was everywhere. It's been going on for so long. We have it in chicken manure, hog manure, just about everything. The human E. coli that is so deadly is everywhere. So that's what I'm talking about when I talk about contamination. Also things like salmonella, shigellosis, botulism. There's all kinds of foodborne toxins. Now, if you cook something to 165 degrees for, I think it's about a minute and a half or 2 minutes, you don't have to worry about any of those things. They are dead. If you eat it raw, you have to be absolutely certain that there is no contamination path from anything onto your raw food before you eat it. Now, where do we go from there? Where we go from there is that anything you're going to eat raw has to be clean. You either have to wash the heck out of it, or you have to grow it in a clean environment, or both. And that clean environment is the critical factor. When you pick that and process it, turn it into a salad, you can wash your hands, you can wash the salad, you can be totally sanitary after you've picked it. But what happens to it beforehand, you also want to control. Now, where do we get into fish food? I'll talk about commercial fish food last. I'm going to talk about homemade fish foods first. We tried black soldier fly larvae, and they sank and the tilapia just look at them on their way to the bottom of the tank, because tilapia are hardwired to eat floating food. Okay? So black soldier fly larvae would work great if you were feeding catfish with them. Okay? Or any fish that will eat it on the surface for the few seconds it's there or on the way down. Now, there's a potential issue with black soldier fly larvae and worms and bringing anything else of that nature into an aquaponic system, and that's contamination. There are a lot of sites out there that recommend growing your black soldier fly larvae on roadkill. Okay? They tell you how to do it. You hang a bucket up with some a dead raccoon or a dead opossum, and drill some holes in it, and they fall out. Now, imagine somebody doing that and taking the black soldier fly larva from that and putting it in their aquaponic system. That's salmonella and shigella at a very minimum, and very possibly E. coli also. So the same holds true for worms, although I think worms are way too expensive to grow to feed to fish. If you can be absolutely certain your compost is all from vegetable sources and your worms are from compost from vegetable sources, in other words, you got your worms from somebody who grew it on vegetable compost, and there was never any horse manure or cow manure or any kind of manure in there, and you keep your compost in a closed container, a closed airtight container, then it might be safe to put those worms into an aquaponic system. But imagine this. What's compost? It's usually a pile out in the open or with a loose cover over it. You have a fly in there that just landed on a piece of dog poo out in the yard, and you have this beautiful vegetable compost that's not contaminated, except the fly just landed on it. And you put some compost or the worms from that into your aquaponic system. You have a potential contamination path. Okay? I'm not saying it's guaranteed. Okay? I'm not saying worms and soldier fly larvae will kill you. I'm coming from the point of view of a commercial grower. Okay? Now, this happened in California in 2003. Remember the spinach outbreak there? The thing?
Yes.
Yeah.
I remember.
Killed 3 people, damaged scores more. People will have compromised kidney functions and be on dialysis for the rest of their lives. If I was that grower, I wouldn't be able to sleep, knowing that my produce had killed 3 people. So imagine that. Imagine, thinking everything's okay, hoping everything's okay, finding out your produce was contaminated and having to live with something like that. Well, the same possibility exists for a backyard grower. And the way everybody deals with it, Marabou, is it hasn't happened yet, so it can't happen to us. We're on the other side of the fence. We can't offer anybody advice unless it's absolutely safe. So the advice we have to give people is we're not certain it's safe to put worms or soldier fly larvae in your aquaponic system. We're not willing to say anything else. We're not going to say, well, it's probably okay and, you should be all right and everything. It's too big a risk. It's not you get pimples if you're wrong. You get dead if you're wrong. So anybody who wants to include those things in their aquaponic system designs needs to do so very carefully with an awareness of microbiology and how contamination can spread. Right? And that's it in a nutshell. So now, homemade fish food. Oh my God! If you keep from getting contamination into your fish food, you can make fish food out of all kinds of things. Well, imagine you fillet your tilapia. The bones and guts and everything, if you grind those up in a meat grinder, are an incredible source of protein and minerals and fats to put into your tilapia food. Okay? You can grind other stuff up. You have some rotten tomatoes. You have some, rotten corn. Chuck that out and use that. What you're looking for is thank you, sweetheart. What you're looking for is a mix that's pretty much like the contents on the commercial fish food bag. You're looking for 35% protein and 25% carbohydrates, 8 to 9% fat with all the vitamins and minerals you need, of course.
And now this is for carnivorous fish?
No, for this
omnivorous?
carnivorous fish. You want to up the protein content to about 43 to 45% for a carnivorous fish like a trout, a pike, or a striped bass, something of that nature. They need much higher protein. Frankly, getting the protein into a homemade fish food is the big problem. And you could put black soldier fly larvae in there. In fact, you could even grow your black soldier fly larvae on roadkill as long as you pressure cooked them for about 5 minutes before you put them into your fish food mix. Pressure cooking solves all kinds of evils. So, and then you grind it up, you spread it out on something to dry. You need to fluff it up enough or include something in it so it floats if you're dealing with a fish like tilapia that will only eat floating fish food. That's pretty much what we know about homemade fish food.
And what do you think about plants and weeds and certain things, or duckweed and shredded coconut, things like that? Can you?
Duckweed.
Yes,
Oh,
duckweed. I know you guys don't like duckweed.
No. No, it's not that we don't like duckweed. Duckweed tried to destroy our farm once. It's much more than simple dislike. Okay. Shredded coconut. Oh my God. Carbohydrates and fat and sugars, ideal ingredient in fish food. In fact, if it's shredded coarsely, it'll float and you may be able to get the fish to eat it without doing anything else. I'll talk about something else towards the end of this talk when I talk about commercial fish food. There may be a problem with coarsely ground stuff. See, fish don't have grinder teeth like you and I do. They can eat a big chunk of something and it comes out the other end looking pretty much the same. So unless it's like a bug or a minnow or something like that that's basically already soft, something hard like coconut might not digest really well. But you got to try it, try it. Don't buy coconuts. You're obviously going to do coconuts somewhere it's tropical and you got free coconuts. Duckweed. We had a guy show up at our first training who said, my fish eat a 5-gallon bucket of duckweed every day. He had fish in his pond and he fed them duckweed. And it was true. They ate duckweed because he didn't feed them anything else ever. Those fish were starving to death. So they ate duckweed the way you or I would eat old shoes or cardboard or anything we could get because we were starving to death. We tried duckweed. The first thing we noticed, because we quarantined the duckweed for 45 days, is that we got crayfish eggs in with the duckweed. And crayfish are kind of like piranha with opposing thumbs, if you can imagine that. They eat everything. If they get into your aquaponic system, they will eat the roots off the plants. They will crawl up on top of the rafts and eat the plants themselves. They will eat everything. They crawl out at night and crawl overland. So if you only have one system infested, they can infest the other systems as well. Really amazing little beast. And people have tried that before, what's called polyculturing with crawfish. The only way it works is if you polyculture with them in rice paddies, because they won't touch the roots or the stalks of the rice plants. They don't eat them. So watch out for crayfish. Mm-hmm. Duckweed. Yeah, we grew the duckweed. We fed it to our fish. We tried to feed it to our fish. Our fish didn't touch it. We starved our fish for 3 days, and they ate a very small amount of it in protest. It's kind of like feeding kids green beans after they've had as much pizza as they want. They've gotten used to pizza. They know that's what food should look like, and they will not touch the green beans. And that's exactly what happened with our tilapia. The duckweed spread out into the system. It grew under the rafts. It grew in the plant cups. When it rained, it splashed up onto the plant leaves, and it nearly doubled the amount of labor we had to spend cutting and cleaning our lettuce for packaging. It took us a year to eradicate the duckweed from our systems. And that man's name who gave us that duckweed, it's a curse word at our house now. Okay? Now, one more thing about duckweed. This is very scientific. You may have heard that duckweed is 38% protein, 34, 30, something like that, right?
Right. Is that dried weight or what?
Yeah, you got it right away.
I remember you talking about this in the training.
Yes, exactly. How can something that is 92% water be 32% protein? It can't. When you dry duckweed down, it is 30% protein on the dried weight. In other words, about 2.6 to 2.8% protein on the wet weight. It's very, very low in protein. Now, as an ingredient for fish food, if you could be absolutely certain you'd killed its little spores or whatever it reproduces from, we think it would be an excellent ingredient. Okay? It's got chlorophyll, it's got vitamins and minerals up the wazoo, and a tiny bit of protein. And we think it would be an excellent addition to fish food. You just have to make absolutely certain you're growing the duckweed in a separate container from your aquaponic system, and there's never any cross-contamination, or you will hate the day that happened.
So on the duckweed, I've had many different kinds of responses to this question in different interviews. And some people say they can't grow it fast enough for all their animals that want the duckweed, including the fish. And then I have people who said they didn't have the tilapia didn't eat the duckweed, but I don't remember if it was catfish or trout that loved it. They went crazy for it.
Something else. Now, how many of these people were running commercial aquaponic systems that their living depended on? Zero, right?
I don't think to the extent that you guys have been. No, one was a backyard system, and that was the trout or the catfish that loved it. And the other one, no, they were both backyard systems. And they were both media bed systems as well.
Okay. So here's my point there. Yeah, and it would pretty much concentrate in the fish tank or in some place you had a little bit of water, not splash up onto your vegetables. There's other problems with media bed systems when you start trying to do commercial operations. They're not as productive and they cost 4 times as much to build. But that's another conversation. See, here again, Maribou, we come back to, you have to ask the question, who is this person who's telling me this information? What is their experience? And that's a valid experience for a backyard grower.
Right, and what is the context of their system and their location and their climate and the fish that they're using and all of that? It's all system.
It's so system. Yes, that's it. So you have to be really careful of making non-system declarations like duckweed is good or duckweed is bad. See, in our system, it was horrible. We depended on it for a living, and it made us spend twice as much labor harvesting our product. Now, in another system, let's say you took the overflow water from the aquaponics, right? And you ran it into a couple of big old duckweed troughs. Now, the water never goes from the duckweed troughs back into the aquaponic system. It just goes into the duckweed troughs when your aquaponic system overflows. You grow all kinds of duckweed there. You'd feed it to your chickens and your sheep, and horses eat duckweed. Cows eat duckweed. They love it. It's an incredible green fodder crop.
Right.
But just don't get it mixed up with your aquaponics system.
So that would be a great permaculture application right there, is taking your aquaponics water to grow something like duckweed without contaminating your system, so that you can also grow the fodder for your animals and integrating animal husbandry with it. Yeah.
Exactly. Now, guess what? That overflow water from your aquaponics system is going to overflow your duckweed troughs at some point. So you ought to have a pipe going from there to your cherry orchard or your peach orchard or your grapevines or whatever else, because it's going to go through the duckweed and it's going to go out there too.
Yep, that's great. I love it. Carrying, the function of the water down to other different productive systems along the way, just like gray water.
Exactly. And then you do all the permaculture things with water. You design your plantings so they retain water and they build soil and, create understory, all of that permaculture stuff.
Yeah, in fact, I'm thinking about seeing aquaponics as a production of amazing water just in itself for fertilization and soil remediation. This is kind of going a little off topic, but it goes back to your story about the soil remediation and the banana trees. And I think a lot of that has to do with the bacteria in the water and how microorganisms can convert, pollutants into fertilizer and be edible to other creatures. And I remember this story about this oil spill in the ocean. And in Texas, they had figured out that you could remediate that oil spill by putting effective microorganisms, EM water in the water, and it would convert the oil into something that was edible to the fish and the aquatic species. So they would convert that back into nutrients, and then they would completely, remediate the water of the oil spill. On the other hand, we use dispersants now because there's a lot of profit in that. It doesn't do much but kill things and all that. But we found that microorganisms do a lot of this work for us of converting pollutants into fertilizers and edible food for other creatures. So I'm seeing that in the same way with the banana trees and turning rocky soil,
exactly.
rocky non-soil into fertile soil. And I'm also seeing the potential of taking the water from an aquaponic system and selling it not only as inoculant for other systems, but as ways of repairing river systems or soil or compost, getting your compost more fertile, or even just fertilizer for soil gardens, and inoculating other systems so that we can keep growing those microorganisms that are so important to the health of the planet. I mean, on so many levels.
Okay, so just do this as a mental exercise. Imagine a gravel parking lot that's 1,000 feet on a side. It's a big, square, flat gravel parking lot. It's got a hurricane fence around it and a couple of gates going into it, and a hose bib over in one corner, okay? And an electric plug. Now, you start out with that. You put your aquaponic system in, and as soon as it's going and you've got a little excess water, right?
Mm-hmm.
You start your in-ground plantings, and you do this in a permaculture fashion where you've got a nucleus that holds the water. You don't plant trees way out in the middle of nowhere. You grow from a center. That center is where the soil develops. It holds the moisture. It's cooler there. There's less evaporation. The plants grow better, et cetera, et cetera. As you expand out from that, you start planting larger plants. You're doing bushes, and then you're doing trees, and finally you have literally after about 5 years, you've got the whole thing covered in 20 to 25 foot tall trees, plus a mid-story crops, things like coffee and so on, plus understory crops, things like peanuts, plus your aquaponic system, which you can now remove and take to the next 1,000 by 1,000 square foot gravel parking lot next door, because it's no longer a necessary part of that ecosystem. You can use the aquaponic system to jumpstart a fertile, self-supporting ecosystem in something that's not fertile and never ever will. I mean, you can pour compost and organic fertilizer on that thing, and
It suck it up and just not even,
it up, and it doesn't hold the water, and you'll get a few crops out of it, and the next year you're going to have to do the same thing, because nothing but what I just described in the permaculture approach will turn that gravel into fertile soil. And so you can do something like this and keep moving. You see how the aquaponic system is almost like the seed for that?
Yeah. It's like the nursery, it's the nucleus of all these other systems. I mean, you could use it in so many ways.
And you could leave it there, but it's not necessary to. You could take it to the next barren piece of land and use that. So wanted to plant that idea.
So we can do portable aquaponic soil remediating services.
Yes, because you were talking about that. You're talking about what are the other products. Well, something you could keep, what's that? It's 100,000 square feet. That's like 2.5 acres. Something that could reclaim 2.5 acres of land and 2.5 acres of land and was movable. My God, think of how many areas in the world the soil is gone and the water is gone. It's not permanently gone. Now, they've done some really interesting work with permaculture I'm trying to remember, it's a desert country in the Mideast, but they've actually reversed the desertification process in a lot of areas.
Mm-hmm.
They're creating oasis, in other words, and they're
Jeff
doing
Lawton.
it out of nothing. Pardon me?
Jeff Lawton, Greening the Desert.
Yes.
With agroforestry and permaculture, mulch, and yeah, I'm very familiar. I know that we can reverse the desertification of the planet. I mean, California is one example of how they're just stripping away the water, and I know that, you know, not only can aquaponics help, you know, for producing food for drought, but I think the water itself can be used to inoculate the landscapes and get more biomass, more organic matter and roots growing down in the soil to hold more water. And I think that is one of the keys of reversing desertification.
Oh, yeah.
Yeah. And the other thing I thought about, which is, again, it's related, but I had a piece of plastic, one of those polyfilms for our greenhouse, that was folded up in the backyard, and over time it degraded. It actually just became little flakes, and I picked up every single flake I could, and I had to leave some of the mulch that I'd added to the soil. I had to pick it up with the mulch because I didn't want to contaminate everything else. So I picked it up. I thought, well, what if instead of putting this in the garbage, which is going to go nowhere except, you know, someplace where I'll never know whatever happened to it, what if I put this in a pile in my backyard with the mulch, so it has some biomass and some organic matter, and what if I fed it the aquaponic water every now and then? Would it break down the plastic? It's just a big question I have, if we can break down plastic with something that's as bacteria-filled, you know, as aquaponic water. If it can convert oil and oil spills into food for fish.
Okay, you're looking in the right direction.
Then can we convert plastic into soil again? That's my question.
Good. You're looking in the right direction. What do you know about mushrooms? Much?
Oh, I love mushrooms. Mycelium running. Yes.
Okay.
How mushrooms can convert oil, eat oil and petroleum, and turn it into. Yeah.
Have you read any of Paul Stamets' books?
Of course, I'm a permaculturist. I love Paul Stamets. I love that book, Mycelium Running: How Mushrooms Can Help Save the World.
Yeah, friend of ours. We met him about 15 years ago. Yeah. Anyway, great guy. So yeah, don't totally look in those, because mycelium and bacteria are going to have all kinds of tie-ins with this hybrid permaculture aquaponics system we're talking about.
Yeah, remediation of all kinds of oil spills and plastic and garbage. I mean, I even heard there's a bacteria from the Amazon forest that they discovered will eat plastic. So if there are bacteria, there are probably bacteria everywhere that we don't know about that eat plastic, and we need to keep working with bacteria and mycelium to convert things that are toxic into things that are edible and heal the landscapes again, and convert trash into something that's non-toxic.
Oh yeah. No kidding.
So that is actually a vision that I have for aquaponics beyond food production, is all the different permaculture applications that we can do with it. And your story with the banana trees and the rock really hit home for me, and just knowing about mycelium running and all kinds of remediation all over the world. More people need to know that this is possible, that we need to work with microorganisms and plants and roots and mushrooms to convert things into byproducts that are actually non-toxic.
Okay. Now, you asked a question earlier, something about what research needs to be done on this.
Yes, actually. So what related topic do you believe needs the most research, development, and experimentation in the aquaponics world?
Okay. Now, what I'm going to speak of is academic university level research, where they've got funding, where they've got biochemistry labs, where they've got tools that we don't have, in other words. The most important research, I think, is understanding the processes of what we were just talking about.
Mm-hmm.
We know what our bacteria do in our system, but we don't know how many of them there are. We're not certain exactly where they are. We're not certain what they like. We're not certain what the dissolved oxygen level they like is, and the water temperature they like, and the acidity level, and the this and the that, and everything else. It's a very, very poorly understood subject, especially by the academics. They have so much wrong-headed ignorance in some of their publications. It's not borne out in practical experience. That would be an ideal thing for them to research. If we could understand more about the bacterial biology behind why aquaponics works, then we'd have a chance at making it an improvement on it. See, anything that puts out more vegetables at the end of the week is a very positive development for the aquaponic farmer, and is only going to make aquaponics more successful out in the real world. Let me give you an example. We had a student who, he put about $100,000 into 4,000 square foot greenhouse and 2,500 square feet of aquaponics system. And because he had an independent income and he didn't need the money, he started experimenting with that. Now, he had a number of disasters over the 2.5 years he operated. One of them was when he took EM on the advice of a backyard organic gardener who had no experience with aquaponic systems, and dumped a gallon of EM into his system a week for 4 weeks. When he called us, his plants were all dying, the roots were all black, the fish were fine. We tested his water and everything, and all the parameters were normal, ammonia, nitrites, nitrates. And we were puzzled. We had no idea what was going on. We were actually a little worried, Maribu, because we thought we'd found something that, here it finally is. This is what is wrong with aquaponics. Whatever killed this guy's system is out there, right? Well, after being there for about a half hour, he said, I wonder if it's that EM I put in. Okay? And I'm going, oh, Mark, you should have told me a half an hour. What is EM? I mean, he describes, okay, well, we'd use something similar to that in our compost called BM, beneficial microorganisms. Mm-hmm. There's 5 or 6 brands out there now. It works great in compost. It killed this aquaponic system's plants. We don't know exactly what happened, okay? But my speculation is, if there's some bacteria out there that can kill an aquaponic system like this, there's got to be one out there that benefits it just as much. That's what the university guys would be really useful for us, to figure that out for us. Mm-hmm. We don't have the money or the time, we got to keep growing vegetables for a living.
Well, that's a great story because, we're talking about bacteria, and effective microorganisms are so great for soil, compost, and also apparently for remediating oil spills. But we got to be careful about what kinds of bacteria we're using for which purposes. And it sounds like in this case, effective microorganisms were not the type of bacteria, obviously, that we needed in the system. And in our systems, we need what? Nitrosomonas, I can't remember the names of the two main ones.
Yeah, they actually think there's a new one in there. The Nitrosomonas, they're calling Nitrospira now. They think there's one called Nitrospira that's responsible for turning the ammonia into nitrites. But Nitrobacter turns the nitrites into nitrates. Anyway, those guys, what do they like? How do we make them happier?
Yeah.
I mean, really, that would mean something bottom line to the farmer.
Yep.
Farming's already hard enough,
Well, that's a great answer for what kind of research and development that we need. And if some university out there hears this, they might have the money to perform those kinds of experiments. And we would, really greatly benefit from that. So I'm glad that we're putting this out there. And that's one question that I love to ask people is what they think, we need more research and development in, so that we can spark more research and development in these topics.
Awesome.
Yeah.
The Aquaponics Association conference last year that I was at in San Jose, there was a fellow, Dr. Nick Savadoff. He's a Canadian aquaponics researcher. he came and made a presentation on biochar and aquaponics, and apparently it had some incredible effects. The only problem is it's also incredibly expensive. I mean, he was using
Unless you
biochar,
can make it yourself.
unless you can make it yourself.
Mm-hmm.
You ought to see if you can find that paper somewhere online. It's a paper about biochar and aquaponics. Nick Savadov, Sabidov.
I will look it up. I actually did interview a guy who does use biochar in his system, and he makes it himself.
Okay.
So that will be another episode from Spencer Curry up in Connecticut, and he does use biochar in his systems.
Okay. Well, Dr. Savadov was using it in concentrations anywhere from like 20% on up to 100% as a potting mixture and getting incredible productivity increases out of that. The problem was, he said you could only use it for 1 or 2 uses, and then you had to get new biochar. So I figured out the cost. You know, our potting mix costs 0.2 of a cent per pot. This biochar would have been 25 cents. In other words, 100 times as much expense for the potting mixture. And it was 100 times as much, and it would have been, I don't know, $4,500 a month on a $12,000 gross. It would have killed the business. So that's the kind of thing. If we can figure out a better way, cheaper way to do that, or a way to do something like that that's cheap, it doesn't cost 25 cents per pot. Anyway.
Okay, great. Well, that's good to know. I'll add that to the show notes, and I'll add a link to this guy's paper as well. I just wanted to ask you if there's any jewel of inspiration that you'd like to give to our aquaponic visionaries out there.
Start small. Start with proven systems. Try and understand the system, not just the little part of the system. Try and understand how your system works. And don't experiment unless you're willing to have the whole thing go south. See, this is probably the biggest problem I've seen with aquaponics people, Marabou. Everybody wants to be the new discoverer, They want to discover something new. So they'll put this thing together and they'll try 8 or 10 different new things in it and just struggle for months or years trying to get it to work. Not understanding that the way to do experiments is you start with something that's working and you change one little thing at a time. And you also need a control. You need two aquaponic systems really to experiment. One where you don't change anything and one where you change that one little thing. That's how you make progress. And unfortunately, there's a whole lot of people out there trying just incredible stews of stuff and hoping it will work. People saying you should urinate into your aquaponic system.
Oh, right. Pneumonia.
Oh, yeah.
I've heard of that.
Oh, yeah. The new research that's come out recently that indicates human urine is not sterile the way everybody has thought all these years.
Humanure or urine?
Human urine is no longer considered sterile by the medical profession. It can carry all kinds of interesting things.
Antibiotics and stuff too, right?
Oh, yes.
Yeah.
Any chemicals in the bloodstream, definitely.
Yeah. I've had a lot of people talk about tomatoes and, the nitrification and not fruiting and all this stuff, and that would be great. I think people would love to have this information. So.
It's easy to grow tomatoes in aquaponics. It's so easy, it's almost impossibly stupid simple. Yeah, if they're having problems, I don't know. People put all kinds of stuff in aquaponic systems, and it doesn't always make them grow better. Sometimes it makes them grow worse. I can't imagine a system that would not grow tomatoes very, very well. You'd almost have to put something in it to get that to happen.
Yeah, I think some people think it's too much nitrogen and at the wrong time when they want a fruit or something like that. Anyway.
That's coming from hydroponics experts or people with hydroponics or chemical fertilizer experience. It absolutely doesn't work that way. We've grown incredible tomatoes in systems that showed 1/4 of a part per million nitrites and 0 part per million nitrates. And we have a measuring strip that goes down to 1 part per million nitrates. We have no nutrients in our systems when we grow tomatoes. It doesn't have anything to do with nitrogen levels.
So do you think if there was too much of nitrogen levels that it would actually have the reverse effect on tomato fruit production? Not the stalks. Some people say they grow great stalks and leaves, but they're not fruiting for some reason.
Okay. Normally, if what you're feeding your tomatoes is a chemical concoction of hydroponic chemicals, yes, if you have too high a nitrogen level, they won't fruit. You have to reduce the nitrogen to get them to fruit. We had a hydroponics guy tell us that. Looked at our tomatoes that were vegging, and he said, oh, you're never going to get any fruit from those. Can you control your nitrogen? Oh, no. Yeah, well, you know, a week later, it started to set fruit. The guy was totally wrong. This whole nitrogen thing is not well understood in aquaponics. It's not a linear progression. Like I said, we have run systems for months or even years with 0 parts per million nitrogen showing. It's just not there, not in the water. The plants are getting it from somewhere, but it's not in the water the way the hydroponics people expect it to be, or the soil people expect it to be. See, they put nitrogen in their soil. They put nitrogen in their water, and they expect to be able to measure that. Aquaponics is different. It doesn't work that way. And we could have about a half-hour conversation about why we think that is sometime in the future.
Yeah, let's do it.
The biggest problem when you hear something like that, you need nitrogen for tomatoes, or you don't need nitrogen for tomatoes, and you go, okay, well, how do I reconcile that with this? Your biggest problem is you don't have all the information. Like I didn't when I was sitting there trying to figure out why my friend's plants' roots were all going black and dying.
Right.
I didn't know that he put a gallon of EM in for 4 weeks.
Right.
Okay. You don't have all the information either. And every single one of these kinds of things we've tracked down, the people have been doing something strange, either in their system construction or their system design. Without fail, we always turn up something weird about how they're operating their aquaponics. We've had people putting battery acid into their aquaponic systems.
Oh my goodness.
I mean, you thought the urine was weird.
Yeah, it's all about the systems. You got to dissect the system and understand what is happening in that particular system, just as in any ecosystem, to really know why something is or isn't growing. Well, great, Tim. Thank you so much.
Get out.
Bye, Tim. Have a good night.
Thank you for listening to the Visionary Aquaponics podcast. To learn more about aquaponics, please visit our website at www.visionaryaquaponics.com. There you'll find more strategies, tips, and tricks to get you started in your aquaponics journey.